chain rule of differentiation. Are we together? We're looking at what? Chain rule of differentiation. Okay? From the word chain, you would realize that it has to do with different or numerous functions. Right? Numerous functions, right? When you say chain rule, the rule that is applied to numerous functions, but I'll give you the actual definition of what chain rule is all about. Okay? You know of polysaccharides. You know of polysaccharides that they are chains of sugar molecules. Okay? Like, of course, we have the starch, we have the chitin, glycogen, cellulose. These are the four major polysaccharides. They have many chains of sugar molecules. Alright? So, what is chain rule? Please put down. The chain rule of differentiation, okay, is utilized in finding the derivatives of functions, with higher powers. Okay? Of functions with what? Higher powers. So when you want to differentiate a function that has high power, okay, not the Boski Paguzi, I'm talking about higher powers like when n is high, alright, when n has a high value and you're looking at a function that has a power, okay, to differentiate that, you need chain rule. And I'm going to give you the shortcut, the very simple formula, the simplest trick to apply when you want to differentiate a function of higher power. Alright? So now please take down. Take down. Now if y is equal to ax plus b raised to power n, ax plus b plus or minus b raised to power n, the y over dx will be equal to n minus 1 times du over dx. This is the trick. Where u is equal to ax plus b. Where u is equal to ax plus b. So your n, you know that n is your power. So whenever you see something like this, plus or minus, plus or minus, because it can be ax plus b, it can be ax minus b. Whenever you see a function in a bracket and has the power outside, all the while we have been doing the techniques of derivative, we have been using just one function with a power 5x squared, 2x cubed, 3x raised to power 9, things like this. Or we'll say 2x plus 5. But we have not done the one that we have to put a bracket and to be raised to power 8. Or 4x plus 9 raised to power 5. This is an example of what we mean by the function of higher power. When you have a function and you have it in bracket, then you have a power. It's raised to a certain power, n. This guy inside here is called your ax plus b. This a, this x, this b. Or ax minus b. You can have 2x minus 9 raised to power 4. You don't have to start doing 2x minus 9 into 4 places. No. No. If it were to be 2x plus 5 raised to power 2, yes, this one will be easy. You can do 2x plus 5 times 2x plus 5 is not. You can call this your u and you call this your v. Then use product rule and solve it. But in this case where you have higher powers, or maybe a power like let's say 2x plus 5 raised to power 1 over 2, how do you even do this? How do you do this? Okay? Now, you can actually simplify this in an algebraic way, but if you want to use chain rule, it will be easier. And that's why I'm giving you the shortcut to that. I'm going to be applying it right now, and I want you to pay very close attention to what I will be doing right now. Okay? Normally in chain rule, you have substitution, which is very long. Chain rule by substitution is long. So to avoid that long step for chain rule by substitution, applying this simple trick can be able to help you resolve a particular function of higher power with chain rule. Are we ready? Now look at this guy. Now let's look at an example. Now giving y equal to 2x plus 16 raised to power 7. Now find dy over dx. Now you shouldn't wait for you to be told that use chain rule. Listen, just the same way if you see 2x over 6x squared as your, let's say, as your y. Do you need somebody to tell you the rule to apply it? What rule will you apply? Quotient. If you see y equals to 6x plus 9, 2x plus 15. What rule? Reduction. So by the time you have been acclimatized with the rules and techniques of differentiation, immediately you see a function, you would know the technique to use in finding the derivative of that function. Now we have a question before us. We are given y equals to 2x plus 16 raised to power 7. How do we resolve this using our chain rule trick? The trick that I have for you, the shortcut I have for you to enable you to get the derivative of this function. Now your y is equals to 2x plus 16 raised to power 7, right? Remember I told you that the formula for dy over dx, or the chain rule of this, dy over dx is equals to n times u raised to power n minus 1 times du over what? Dx. Times du over dx. So you have to first of all state what u is and what du over dx is. You don't have v here. In this one you don't have v. So it makes it easier. Now your u is 2x plus what? 16. Du over dx means u is everything that is inside this one, not the power. Are we together? U is not actually having any relationship with the power. U is only what is inside the bracket. Now your du over dx means differentiate u with respect to x. Differentiate this guy here. So 2x plus 16 will give you what? 2. 16 is a constant, so that's 0. Now the next thing here to apply is of course the formula. We told you that I told you that n times u n minus 1 times du over dx is the formula to actually apply when differentiating this kind of function with a higher power. So this will now be equal to n is 7, so you bring 7 down. 7 times, what is your u? 2x plus 16, put it in a bracket. Raised to power n minus 1, 7 minus 1 times what? 2. Du over dx is 2. I see it. So now this will be 7 times 2x plus 16 raised to power 7 minus 1 is what? 6 times 2. Now, you cannot multiply 7 by this. Reason is because it has a power. And you are not even expanding, you're not expecting rather to expand this guy. It's not your business, don't even try it. You leave it like this till you have the final answer. Rather, it is only the things that are outside that you multiply. Am I communicating? Only the things that are outside that you multiply by each other. So if you have 7 times 2, 7 times 2 is what? 14. So this will now be 14 bracket 2x plus 16 raised to power 6. This is your answer. Dy over dx. Simple. So it's only the entities that are outside the brackets, outside, that you can multiply. 7 times 2, 14. Bracket 2x plus 16. You cannot, don't even expand. This is how it will remain. Alright? This is how it will remain. So this is the general understanding of chain rule when differentiating functions with higher powers. Alright? So you'll be trying to write it. Now if y is equal to 17x minus 5 raised to power 1 over 2. Okay? Find dy over dx. Okay? Find dy over dx using chain rule. Alright? You can also try this. Find dy over dx for this. Let's say you have minus 18x minus 21 raised to power minus 5. You have something like this as well. Okay, also find the y's and the x for it. So you try it. Okay, so that is the concept of chain rule.